basically want to talk about Apache and how you can leverage Apache to make your site faster. And some of you probably already know all this stuff, and hopefully some don't. Hopefully it's a learning experience. Guess the first question is who am I and why should you listen to me for an hour? I'm Devon, and do web application architecture. Been doing it for 14 years now, which dates me a little bit. I built 10-minute mail. Anyone here ever used 10-minute mail? One, two, all right. Thanks. I built it kind of just to teach myself JBoss Seam programming framework, and I launched it and I told a couple of my buddies about it, and then the next day it was on the front page of Yahoo Tech /.and-dig, which drove just a hilarious amount of traffic. And it didn't fall over. It got really slow, but it didn't fall over. And right now it does maybe 150,000 pages a day. So for a small personal site, it's pretty good. You know, it's not Fortune 1000 level, but see some traffic. I've also worked at some really large companies and worked with really large websites. So AT&T, Wireless, Singular, AT&T, through the mergers and acquisitions. People's Choice Awards, Payless Shoes, Vermont Country Store. People's Choice Awards is really interesting. They're one of the ones that we host, SparkRed, so I'm intimately familiar with a lot of their technology and a lot of their traffic. Most of the year, everyone familiar with the award show? Annual award show in January, nationally televised. Yeah, some people. Yeah. Most of the year, very, very little traffic on the website. It's, you know, they have polls and some social stuff going on, but it's, you know, kind of middling. And then as they ramp up to the show, they start generating significantly more traffic. They start doing national ad buys, getting a lot of people on the site. During the show, nationally televised on CBS, they have multiple call-outs for Vote Now. And on the TV pops up, go to www.peopleschoice.com. And it drives these amazing traffic spikes for 60 seconds, for 120 seconds. We're talking gigs a second of bandwidth, hundreds of thousands of requests a minute, just massive. So we've had to figure out how to scale up for that, how to build an environment that works for them when they're running a small cluster most of the year, and then scale that up to handle these incredible loads that come in during the show. So I've got a pretty fair bit of experience dealing with web applications under load and how to make them perform. Yeah, my email, devon@sparkred.com. If you have any questions, feel free to email me anytime. So first I want to just talk about a little bit what is performance. And in my mind, performance breaks down into two categories. One is server-side performance. So we're talking about, on the back end of things, what is the server doing? How much capacity can it handle? How many requests can it address? How quickly can it address those requests? And then resource use, CPU, bandwidth, memory, all those things. And then how scalable is it? So these are all things that relate to, on the back end, how much traffic can you handle, basically, and how can you scale? The other side of the coin is going to be client-side performance. So this is what the end user sees. This is how quickly pages load. Everything from when you first get the first draw to when you can interact with the page to when the page is completely loaded. And how quickly you can start performing actions on the page. So whatever you're on that site to do, whether it's voting for your favorite TV star or whether it's purchasing something on Amazon. How quickly can you get to what it is you're trying to do? And there's a bunch of things that kind of factor into that as far as how you're serving the resources to the browser, headers that are being served with those resources, how small those resources are, or how large, how far away they're coming from. If you're serving off of servers that are very geographically or network distance, stuff loads slower versus quicker. And how can you deal with that? So I guess I really see it as two different stacks there, and I think all of that is web performance. And they're related. Solving for end client performance helps alleviate a lot of the pain on the server side. So for instance, setting cache headers in images, JavaScript, and CSS. If you tell the browser, once you load this, it's good for a month. Don't bother loading it again. Well, you made the browser pages respond quicker to the user because their web server, or sorry, their client isn't going out and making 100 requests for every page. But you've also taken a lot of load off of the server because the server isn't handling those 100 requests with every page load. So by trying to solve for the user's experience, you can, in a lot of ways, solve 80% for the server-side experience as well, which helps you scale and handle more traffic for less money and less hassle. I don't know if many of you gearheads, but there's a saying, if you're building big motors, don't build for horsepower, build for torque, and the horsepower will follow. Same kind of thing here. Build for end user performance, server-side performance comes right along with that. There's still some more stuff to do in the tweaking of the server-side performance, but it gets you 80% of the way there without focusing on it. Why should I care? This is one of the things that as a developer, a lot of times you want to write cool functionality, you want to write cool code, you want to write stuff that looks nice or works well, but a lot of times performance isn't at the forefront. Now obviously if you're here in this room, you care, and some of it's technically interesting, right? It's a challenge to make stuff faster. But honestly, a lot of it is related to business. You get happier users, increased conversions. Google's now taking page load time and site load time into account for your rankings. And then server side, you need more capacity on the same hardware, which means less cost, means more profit, means more scalability. Means you can do ad promotions and marketing promotions without having to worry about it. There's a lot of companies out there that might have a opt-in mailing list of 10 million people, but they can't send more than 1 million emails in a day because their site can't handle it. And they're missing out on a big opportunity there. So there's a lot of reasons to focus on this, and a lot of business, both from the bottom line, the money side, but also from happy users. There's a lot of win available here when you're making a site faster. And everyone's seen these stats, I'm sure, but they're worth repeating. So Amazon saw that an additional 100 milliseconds page load time, 1% drop in sales. It's big money on Amazon. Google, half a second, 20% drop in searches. This is when they were trying to pack more results on the same page. They saw people were using it less. It's a big number, 20%. And 500 milliseconds, it's not much. When you're talking about a lot of websites out there, it's a very small amount. It's easy to optimize that in, or to do something wrong and lose that. And then Yahoo, they did something at 400 milliseconds page load time, and they saw up to a 9% increase of people hitting the back button before the page loaded. They click a link, they wait, they're bored, they click back. It's a lost opportunity and an unhappy user. And these are all pretty small amounts of time, half a second. It's not much. Things are different now, obviously, 10 years ago, you'd wait 30 seconds, minutes for your page to load, but people are really expecting stuff to be a lot faster. I guess the reason I bring this stuff up, I know this is kind of common knowledge, but performance optimization is not ivory tower technology. It's not, pie in the sky architectural design. It's direct impact on the bottom line for any, and not just e-commerce. I mean, e-commerce is easiest to apply that to dollar value, but any business where you're having people interact with your website, you want people to sign up, you want people to come back, you want people to tell their friends, you want conversions, whatever it is you want them doing on your website, performance has a pretty significant direct impact on that. So it's a good place to sink some time in. Yes?
So what happens if you add an advertisement to your page which makes your page load slower but increases your revenue significantly?
Most of the ads, I run Google ads on some of my sites, for instance. If you have them loading asynchronously, if the page content draws and the user is able to do what they came to do, they're not going to leave. Right. Even if that ad then loads up half a second later, their eyes are already focused on whatever they're doing, and you're still going to get that ad revenue. If you have a situation where you have the ad that's blocking the page load time, or you're not rendering down to the fold while you're waiting for a slow ad resource, you have to do your own metrics, right? Whatever your cost per click is. I think in general, the most of the good ad providers out there are doing asynchronous loading, so it's really not that big of a deal. There are some people who it's really all about when the little spinny icon stops, right? Regardless of if the page is loaded. But I think, especially with more sites doing interesting things with Ajax and tracking bugs, sometimes this thing never spins, never stops spinning. So I think people are getting used to that, and it's really all about, can I see what it is I came here to see, and can I do what I came here to do? And as long as your ad's not holding that process up, I don't think you have anything to worry about. All right, so why Apache? So I use Apache, both personally and professionally with SparkRed. and I don't use Nginx, and I don't use many of the other options that are out there. And there's nothing wrong with those options. Nginx, very, very fast, very highly regarded, runs a lot of really big sites. IIS, actually very fast. Twitch. But there's a lot of really good web servers out there, and I just use Apache. Why is it's everywhere. When I get a box set up by my data center, I get Red Hat on it or whatever. Installing Apache is yum install HTTPD, done. Supported by Red Hat or whoever you're dealing with. Every box has Apache. You can get Apache on every operating system. It's free. It's kind of the default. And that does bring some nice stuff. It's easy to find information on it. If you have an issue or a question, you can Google it. And because Apache's been around for a decade plus and tons of people use it, it's very easy to find good information on your issue or your tuning or whatever it is. It's also pretty stable. Yeah, there we go, mature and stable. Lots of extensions. Lots of people write modules for Apache. Obviously, Apache ships with a pretty extensive collection of modules, but also Google writes mod page speed for Apache. JBoss writes mod cluster for Apache because it's the leader kind of in that space. So you get access to a lot of third-party tools that might not be available on some of the other web servers. Sometimes you might have enterprise support requirements, and you can get really good support both from your OS provider and also people who do good Apache support. So if you need 24/7 coverage for someone who supports Apache, it's easy to find companies that provide that. And here's the big thing for me. It may not be as fast as some of the other options out there, but it's absolutely fast enough to max out your hardware. It is not the bottleneck 90% of the time. There's edge cases, right? There's edge cases absolutely where you have CPU intensive PHP application, or you have, maybe you're streaming large files and you're tying up a ton of threads doing that, and there's better platforms for that. General website use, Apache is almost always totally able to completely max out your network connection before it runs out of CPU resources or memory use resources. You can set up a VPS with like a single core and 1 gig of RAM and, sure. But in general, it works out pretty well. So here's a performance graph comparing CPU utilization at bandwidth saturation of a 1 gig NIC. So realistic 930 megabits a second. That's how much CPU utilization is being used for each of these products. You can see that Apache is certainly worse than Nginx and IIS. But here's the thing, Nginx is using 21% and Apache is using 27%. So we're talking about a 6% CPU utilization difference, just completely saturate a 1 gig NIC. Who cares? No matter what else you're doing on that box, that 6% is very unlikely to make or break your application or your site. And so the win of all the stuff I talked about before that you get with Apache being kind of the standard and being stable is totally worth that 6% penalty loss from my standpoint on the CPU. So your real limitation becomes your bandwidth, right? You can get boxes spec'd out with bonded 10 gig E-cards, but typically a server that big and beefy is going to have enough processor to drive that kind of stuff. This is with a single proc, right? This isn't we're not throwing tons of CPU in there. Real life example, People's Choice Awards. This is a screenshot from IFTOP, which shows network usage on a server. You can see here, in and out, 613 megabit a second. So we're not quite saturated in a gig NIC, but that is a absolute truckload of traffic. This is one of 5 servers. So we were pushing, I don't know, over 2 gigabit a second out of a small web cluster. CPU was not a problem on these boxes. I think the CPU load was probably 1.5 or 2. These are quad-core boxes, so not a big deal. So you can see that you can push as much traffic as you possibly can push out of one of these boxes without hitting CPU limits, without hitting memory limits. People's Choice Awards, what I talked about earlier, this year we hit 4 times their planned traffic. So they said, hey, we need to be ready for this traffic. We're going to load test it, we need tuning, we need to be sure it can handle that. Show came, we had 4x that. Totally unexpected. We saw CPU load on our app tier and our database tier spike. You know, we had the moment of panic. Site stayed up, site was fast the whole time. And the Apache instances, the web servers, they never got above a load of 5. And these are hex core boxes. So 5's no big deal. Let's see, 2012, we were pushing 2,333 pages a second out of the cluster. And those are actual pages, those aren't assets. So those are actual page loads. The year before, we didn't have an Akamai CDN in front, so we actually pushed over 3 gigabit a second. This is with 5 web servers. This year, we did have Akamai, which offloaded a huge amount of the static assets, JavaScript, images, CSS, and we were still pushing 1.2 gigs a second out of the web cluster, just with raw HTML page requests. And Apache was not the problem. Yeah, quick, fast, you click around. You know, there was no degradation in performance as we hit these spikes that were 4 times what we tested for. We run, take a little step back, I touch on this a little bit later, but we run a 3-tier architecture at SparkRed. So we have web servers up top, we have application servers running JBoss, we have Oracle servers as our database platform. And we run a lot of very high traffic sites, People's Choice being one of them. The bottleneck is never on the web servers, never ever. JBoss, yeah. Oracle, it happens, but Apache has never, ever been the problem, no matter how much traffic we're pushing through it. Puppies. Break here, cute. All right, so now we talked about, yes. So I'll go back to the puppies for you.
Yeah, one more on the puppies. The benchmark, what version of Apache was it? I was just wondering.
2.2.
Okay, so it's not
Yep.
the latest.
No, this is on 2.2. 2.4 is faster.
Yeah, that's what I heard. I was just curious.
Yeah, I did a little bit of playing with 2.4, but not as much as I'd hoped to. I was hoping to have nice 2.4 versus 2.2 stuff. I don't. But 2.4 is faster. But yeah, this is all based on 2.2. So then we talked about why you care about performance, and we talked about why I use Apache, and why I'm here talking about Apache, instead of talking about something else that might be faster, might have these advantages. For me, it works. I don't like to overly complicate things. So one of the problems with Apache is that the default configs, and most of the recommended performance configs you find online, are amazingly outdated. They are from a decade ago. They're designed for a site running on a server that's got 1 gig of RAM. They're not applicable for modern hardware. Yeah, right now, the Sandy Bridge E5s are the current latest and greatest processors for servers. They start at hex-core and they go up to octa-core. And they're hyper-threaded. So the octa-core boxes present as 16 cores, right? Huge processing power. You're running a big app, you're running 8 gigs, 16 gigs, 32 gigs of RAM. You've got all these resources and the basic configs, and even if you search for like, worker MPM config performance or whatever, you'll find people who talk about how to configure it. And you look at the post and it's from 2001 or 98 or whatever. And they're just not dealing with the boxes and the resources that we have. They're not dealing with the web browsers and the client bandwidth connections that are currently available. At home, I've got a 40 megabit connection, right? The way that my web browser interacts with the web server is very different than 10 years ago. We also have applications that are very different in how they're built, in how media rich they are, in how they're using Ajax, in the complexity of the site. And so a lot of the configs you find for Apache are terrible out of the box. Just absolutely awful. So one of the things I want to look at is some of the configs, how to do it better. The gotcha to that is that every app is different, right? Every application performs and has limitations and bottlenecks and kind of choke points that are very different from each other. So my app, if I spend a week benchmarking and I set up realistic tests for my application and I start tweaking MPM, start tweaking all the little settings, and I fine-tune down to just the absolute peak performance for my app, it's not the same for your app. It's not the same for your site or anyone else's site. So, and that's true as the hosting provider problem too, right? We host a bunch of different websites. I don't want to spend a week narrowing down to get that optimal config for each different client. So what I do is I try to find something that works in general for everybody. First question is which MPM, right? MPM, people familiar with that? Apache has different ways of handling requests. The default one is the, not worker, not event.
Pre-fork?
Pre-fork, thank you. Default is pre-fork. Pre-fork spins up a thread for every request, basically, which is kind of bad. But the advantage is if you have code, say older PHP modules, most of which are fixed at this point, but it was a big problem initially, that aren't thread safe, you're stuck with pre-fork. You burn a lot of memory spinning up this thread and CPU context swapping to handle this thread. It's not very optimal. So we use Worker. Worker basically handles multiple requests on a given native thread. Spend less time tuning the configs. The big issue with Worker, again, if you're using non-thread safe code. Not on the slides, but I did a little bit of tuning with, or sorry, a little bit of performance testing with Apache 2.4 and the event MPM, which is a new one. It does asynchronous request processing, basically. Default configs were about 5% faster than my tuned NPM configs. So I haven't had time to keep playing with it, but the potential's there to get some pretty significant gains out of the event NPM. So definitely something to look at if you're kind of playing around with stuff. There we go.
Could I ask you about that?
Yes.
So I look at the Apache documentation, and under event, it says, not fully tested, not guaranteed.
Right.
Should I, it was written a while ago, should I still worry about that?
It's a lot of burden on me right here. The testing I've done on it was very minimal. I installed it, I set it up, I ran some benchmarking against it, I compared it to the numbers I was getting with 2.2 Worker, right? And so I was like, yeah, it's faster, great. I have not deployed it into a production environment. It will be a while before I do that. But the Apache 2.4 stuff is relatively stable at this point. They've been testing it and hammering on it internally and in beta for a while. For my personal sites, I wouldn't hesitate. I'd go ahead and push it out there, and if something breaks, I'd swap it out for Worker and I'd figure it out later. For Payless shoes, I'd test it in stage. I'd load test it, I'd UAT test it, I'd hammer it for weeks on end. But in general, Apache MPMs, I've never had critical problems with any of them. I've seen issues with other Apache modules, but the MPMs generally do what they're supposed to do. They might not do it the quickest, but I've never had, Apache just saying faulted on me because of using one NPM versus another. So I guess it really depends on your use. How's that for a weasel answer?
It sounds like a great idea because it solves the Keepalive problem.
Yeah, so, yeah. I guess for anybody, if you're in a position where you have a good test environment, I'd test it. If you're in a position where you don't, I might test it in production. I might put it out there and just watch stuff really carefully. And be ready to swap it out at a moment's notice. But I think the advantages are pretty significant. And, you know, I think the risks are pretty low. Obviously the documentation, right, there's a lot of CYA going on. But it is available in the production release. So, I don't know, I'm a little bit of a risk taker. But.
And in Apache development, if it's available in production in 2.4, do you think they backported all their fixes to 2.2, or is it actually the same in 2.2, or what?
I think they only backport critical bugs and security stuff. I think beyond that, like I don't know if they're going to do like the full event stuff in 2.2. I don't know. Yeah, not my particular expertise, but yeah. All right. On the left, you see the default Worker MPM config. It's not big enough. So on the right you see mine, much bigger. This isn't tuned. Like again, I haven't spent weeks tuning this out. I started playing with a bunch of values with some high traffic production clients and tweaking, and this works. This config has not fallen over under any amount of load that I've seen in any production client of mine. So take that with a grain of salt. Your situation, your application are different. These settings seem to let Apache run under almost any level of load without running out of memory, without burning CPU, and without denying requests, which is the big problem that you run into over there. The defaults under any significant load, and I'm not talking, you know, hundreds of requests a second. it starts running out of resources. And then you start getting connections dropped. So that's what I use. It might be a good starting point to tune your own, or just take it, and if it works, great. Yes?
Sorry, sorry. I just happened to have been looking at this in the last week, and I'm puzzled over server limit. You have to remember what that's for?
You have to bump server limit up from the default of 100 in order to get the max clients up. I'm trying to remember how this worked.
Is it the maximum number of processes? Is that?
Yeah. There's. I should be speaking this more smoothly here. Wow. If you put those numbers in without server limit, because you see there's no server limit there on the left, it complains, and it says you can't set the max clients that high without increasing the server limit. So you have to bump the server limit up, because the max clients is computed by server limit times threads per child times thread limit, I think? Yeah, there's good math there.
There's calculations and
Too much.
built in anyway.
Yeah, there's calculations, and basically Apache says no until you put server limit 200, and then Apache says great, and runs happily.
Okay.
Yes.
Should I be writing really fast, or will your slides be available?
Hopefully they'll be available.
Oh, yeah.
Awesome, yeah, I'll totally send those to you. Yeah, I don't expect people to be taking notes. And again, I'm not saying this is the gold standard. I'm saying this is what's worked for me across a lot of very high traffic sites, a lot of different profiles of applications. Giant e-commerce sites, social media sites, 10-minute mail, so big and small, high traffic, yes.
What's the oldest or I guess weakest server that you run a similar config on? So meaning, so if I have the Pentium 3, sitting in my closet, obviously I wouldn't run that.
No.
I don't have a 32 gig of RAM hex core machine at my disposal.
Right.
Should I still be running a similar config?
Smallest server that I run that on is a single quad core with 4 gigs of RAM, and it worked fine. If you start saturating with tons of requests, you might run into memory issues depending on how many modules you're loading, right? So if you're running PHP environments, you burn a lot of RAM per thread. And obviously Worker is way better than Prefork, but there's still some memory burn there. If it's lightweight, you're serving static assets, or you're using mod proxy, things that have relatively low RAM usage per thread, I think you'd be fine. We run out of some bigger boxes now, but single quad core, 4 gigs was our standard 2 years ago for the 11 tier, and it worked great. Yes?
Even though it's your mileage may vary, I thank you, because you probably saved us all 8 hours to find a base from which to work out from.
I hope so. Thank
So
you.
yeah, I mean, even though we need to tweak, it's great to have a baseline to work out from.
Yeah, and that's the thing is I start tweaking per client, and I just realized I drop this in, and everything works. And there's no issues, there's no complaints, there's no problems. So that's what I've been doing.
Go with it.
Yeah. All right. One thing I did want to mention is I've got max requests per child set to 0. And that basically means that every child thread lives indefinitely. If you have a situation where you have a memory leak in your PHP code or in whatever, some Apache module that you're running, you want to set that to a specific number, like 5,000 or 10,000 or whatever. And that means that thread will get killed and recreated after that many requests. So you can kind of rein in your memory leaks before they get you into trouble. So it kind of depends, again, on your application, but something to be aware of with those numbers. So really basic testing. We're using Apache 223 in the worker mode. I'm using an Apache recommended small document. It's basically a head and then like a hello world kind of thing. And the single server, it's a single proc hex core Westmere, so it's what, 3 generations back now. It's beefy, but it's not new. And the numbers I was running, 1,000 concurrency level, 100,000 requests, and it was pushing 20,000 requests a second through the Apache instance. CPU load was a load average of 2 on a hex core hyperthreaded, which is nothing. Yes?
What kind of box are you running AB on?
Identical configuration.
Because I always tend to max out AB before I max out my set.
Yeah, I don't know what was maxed out, but everything seemed fine. But it's identical servers, 12 gigs of RAM, hex core box, single proc. So you can push, for small static files, easily 20,000 requests a second off of a single box, which is more than most websites need. And throughput wasn't that great because the files are so small. We bumped the file size up to a large HTML document. I stole this off the homepage of a large e-commerce site, very complex, about 100K of HTML. Everything else the same. Requests per second dropped down pretty dramatically, down to 1,200. You can see the throughput goes way up because we're pushing larger documents. Again, this is the sort of thing where your own application is going to require different tuning. These are all using my default config, right? So if that's all you're doing, there's probably a better setup for you. They'll get you a little bit more throughput, a little bit more requests a second. But 1,200 requests a second, pushing 100K HTML documents, is a lot of requests a second. Not many websites that push that kind of traffic. Yes?
Well, what's your number of open files that
U limits a lot. Probably 4,000. Double check. I do have some of the syscontrol control stuff a little bit later, but I don't know if I've got the U limit stuff.
the most OSs by default that's set to either 256 or 1024?
Yeah, I bump all that stuff up. And if it's not in my slide, I'm happy to let folks know what I use. We have default configs that we image these boxes with that includes all that stuff. Good question. So yeah, kind of short of it is that Apache can push some pretty serious traffic using a very basic non-tuned config. And this is with all the default modules loaded into. So it's not streamlined, it's not stripped down, it's out of the box. Yum install HTTPD, it goes. So here's some of my kernel configs. I don't have the ulimit stuff. This one at the bottom is important if you run IP tables or any Linux firewall, which you should be. So the problem is the default connection track maximum is something pretty small, 64,000-ish. And so under high traffic, it runs out of slots to store the connections that the firewall is tracking, basically. And at that point, for security purposes, it denies all the incoming connections. So you can totally bottleneck yourself. Apache looks fine. The Apache logs are fine. Your Apache status is fine. Your load is fine. And you have no idea why the site died. And your firewall is quite happily, quietly dropping packets until the connection table comes up. So I bump it up. This is like 4 or 5x default. I don't even remember where this number came from, but it's big. You'll look, and again, this is one of those problems where the default config is set up for 10-year-old hardware, right? The reason that this is usually set small is because it takes memory to hold all these requests or all these connections, right? And that there's a little bit of CPU power needed to look through these connection tables and determine, is this packet part of an existing connection, and therefore which firewall rules do I apply? Problem is, modern hardware, modern RAM amounts, you can bump this number way up without getting yourself into any trouble. And if you don't bump it up, you'll get into trouble. So there's a bunch of little kind of gotchas like that. Yes?
Just curious, given that you know you put in, you're looking at the logs and all that, and you're saying everything's fine, obviously there's some limitations. How were you able to isolate? That's what you needed to do.
This shows up as a one-line warning in syslog that says something like, connection tracking maximum reached. And it goes, huh, all right. And you look into it, and you're like, oh, once that happens, it drops packets. Every incoming request gets dropped until the condition clears itself. So it does show up, but it's not, you're sitting there and you're seeing 10,000 requests failing. And you're looking at the Apache logs, and the Apache logs are happy. And you look at syslog, and you're not seeing tons of errors. You look at your firewall log, and you're not seeing tons of anything. The kernel is just happily dropping stuff with one little warning log line. Yes?
Threw one warning on the first one, and now the rest are just
And then
silent.
it just drops packets until it clears, and then it starts taking requests, and the next time it hits the limit, throws another warning log.
Wowza.
Yeah, so that was a fun one. And we've hit this every time we've forgotten to set it up. So it does not, I'm not talking, you don't have to be Payless Shoes, you don't have to be People's Choice Awards to hit this kind of limit. You do have to be more popular than your average like Apple Pie blog, but it doesn't take that much. So something I did want to mention, even though it's not Apache specific. All right, Keepalive. This is a great subject for debate, on or off. So on the upside, Keepalive keeps you from having to establish new connections for every request if it's coming from the same browser. The downside is if you leave these connections open, you're going to be burning CPU, you're going to be burning memory, you're going to be burning sockets and file descriptors and all kinds of stuff that you don't want to be wasting. So a lot of people say just turn it off. A lot of people say the first thing I do when I install Apache, Keepalive off, done. I don't do that. I turn it on, but I turn the settings down. So the default settings are 15 seconds and 100 requests. Previous versions of Apache, it was way smaller. Again, bad defaults. In general, if your website is taking more than 6 seconds for the browser to issue all the requests, you need to fix your site. So I think 6 seconds is pretty good. Again, your application may vary, right? If your application, if end user browser testing, all those requests for all the assets on your site are made within 3 seconds, turn it down. If it's more complex and they're made within 20 seconds, turn it up. Generally, you want the Keepalive session to be open as long as a given page load assets are being pulled by the same browser, and then you want it to die as close to after that is done as possible. And then also the number of requests, default of 100. A lot of sites out there put more than 100 assets per page. They shouldn't, but they do. So I find 100 is usually too small for at least more complex sites, e-commerce sites, that kind of stuff. You get pages that'll pull in 150 assets. And if your max for Keepalive is 100, you're creating another connection. So that's what I like to do. If you're using a CDN in front, like Akamai or whoever, they'll usually have some advised configs. I think Akamai's is 120 seconds. Because the end browsers aren't making a request to your server, the Akamai edge servers are. So those edge servers are making a lot of requests for a huge number of browsers behind them. But because they're making all these requests, it doesn't make sense to make them open up a new connection every 6 seconds or every 500 requests, because they're going to be issuing tens of thousands of requests over an infinite amount of time. You don't want to set it crazy high because you do burn some power, and you do want them opening up new connections so you don't have really long running connection handling. But ask your CDN provider for what they recommend. They'll usually have a good set of settings for you. So something, yes?
Without a CDN,
yes.
Your first case, if you say set to 6 seconds, and my page load takes 5 seconds, does the Keepalive finish after 6, after the initial connection, or is it 5 plus 6? Is it 6 idle?
I believe it's 6.
Uh-huh.
I believe it's not idle counting. Anyone know differently? I don't know 100%, but I believe it's from the start. I believe the limits are set up so you don't end up with situations where you're opening a connection for the length of someone on your site, right? So they click on a page, default's 15 seconds. A lot of times people click a link within that 15 seconds. It's not intended to span multiple requests. So I believe it is just from the initial request, counts down, kills the connection, you get a new connection with the next request.
Okay, thank you.
All right, on the kind of fun stuff you can do with Apache, ModDeflate is great. Who here uses ModDeflate? Anybody? All right, so yeah, ModDeflate basically gzip compresses assets for you on the web server. HTML, JavaScript, XML, CSS, a lot of that stuff can be compressed up to 90%. Most of it can be compressed at least 50%. So you save a lot of bandwidth that you're using on the server side, and you save a lot of bandwidth that you have to push down to the client connection. For people on 40 megabit fiberless connections, not a big deal. For people who are not, there are people who are on phones, there are people who are on different continents. It does make a really big difference in page load time. So this is one of those things where you gzip it, and the end client gets the page loaded significantly faster, depending on their connection and everything else. But also, you're taking a lot of work off the server because you're pushing less bandwidth out. So you're using less of that 1 gig NIC than you were before. The other piece, and this kind of depends a little bit on your application structure and all that, but because you're serving out, let's say 10K instead of 100K, 100K HTML document, gzip it down to 10K. Because you're serving that out over some limited pipe to the end client, on the server side, your request handling thread is done 10 times quicker. Okay? Which means that thread can now handle another request. So you can have, in theory, 10 times the request throughput because you're handing out smaller response bodies. All right? So optimizing for the front end user dramatically increases the capacity on the server.
Does it manifest itself as a longer perceived time for the user? So like if the user is at a page that has a lot of AJAX requests, and you're gzipping all these AJAX requests that have really small content, are they actually waiting or perceiving the wait to be longer to have to gzip something that's smaller and we're just downloading faster without the gzipping?
There's probably some trade-off, although I would worry more about the CPU on the client than on the server side, because when I get to it in a second, we can do caching, so we're not gzipping at every request, we gzip at once.
One thing you can do is set the minimum, the size that you want to gzip, so don't gzip anything smaller than, say, 1 gig.
Yeah, that seems smart. But again, this is kind of like 10 years ago versus now.
There's also, so if you gzip something too small, the gzip output is larger than the...
Because you're padding it with the...
well, because of the additional headers.
Yeah, that's true. One thing, and yes, also, 10 years ago, you'd see a reasonable amount of client and CPU utilization decompressing 100 assets that come in gzipped, right? Now we're running i7s on our laptops, so that side isn't that big of a deal. But yeah, there are definitely situations, especially for AJAX, I think in particular, where you're dealing with small response bodies, where it may not make sense. Again, your mileage may vary. That's kind of like my repeating theme tonight. This is my config that I use to start with. I do header unset vary, so I clear out all the vary hosts, or the vary headers. This ties into a situation you can get yourself in if you're using ModDeflate and you're using ModCache. So ModDeflate cares about the browser, the user, because there's certain user agents that don't support gzip for different file types. And if you start doing a bunch of interesting stuff with Flash apps, pulling XML documents, you'll find some more problems where the browser can load a gzipped XML file no problem, but certain versions of Flash cannot, and they die horribly. So you may tweak this kind of for your application. You get into a situation where you're disk caching many copies of the same asset because the vary header for every value creates a new copy. So I like to clear it before I start doing any of this stuff. And then it'll set the appropriate encoding type header, so you get the gzip version and the non-gzip version cached, which then serve the correct one to the different browsers. Yes?
Can you pre-gzip static content?
That's a good question.
So Nginx has a gzip static flag where you can just do .html.gzip.
Okay.
And just serve that instead of gzipping on the fly.
Okay.
I think Apache can do that, but I'm not sure how.
It might, I don't know. What I do is I do this and I do mod disk cache, and it caches the gzip version, so I'm only gzipping it once, but yeah, it may. I don't know what I'm talking about. That's a good question. All right. Browser caching. Basically, you can set specific headers on your response. It goes back to the browser that tell the browser and also tell any intermediary proxies that this content is safe to cache for this long under these conditions. And that's good because it means that on most websites, a lot of your static content is going to be pulled on multiple pages. Your JavaScripts, your CSS, your sprites, a lot of your image files might be the same page to page. Or on your home page, you might have users who come visit your page 5 times a day or 5 times a week. And if they're only pulling all those images once, it saves them a lot of page load time and it saves your server a lot of request handling time. So again, optimizing for the user helps the server. Set the E tag, you can set the cache control and expiration response headers. There's a bunch of different ways to do this. So Apache offers several options for handling this. If you're running a 3-tier application, your application server offers different ways to handle this. On my blog, I've got a JBoss filter that lets you set expiration times for assets served out of JBoss if you're not using Apache. But this is pretty straightforward. So we say we build the E tag, which is basically like a unique identifier for the file that says this version of the file has this kind of tag. So we use the last modified time and the size as the two things to build that E tag with. So it basically says, you know, when was the file last modified at the server and how big is it? If someone makes a change and the size doesn't change, the E tag will change. But if the size is the same and the modified time is the same, it's the same file. So we're not going to worry about resending it.
How likely is it that the size changes but the modified time doesn't?
It should never happen.
So in that case, the E tag is no different from the last modified time. Which means you could just drop it and drop the header as well.
Cut that for a second. I think you're right.
Unless you have multiple boxes in a cluster which could have a different modified time.
Yeah, although that's going to break regardless. I'm stumped on that one. It's a good question. I might have this. That might the M time might be unnecessary. Although no, I mean sorry, the size might be unnecessary.
Right. In that case, you just don't need the E tag. Because last modified is going to be sent anyway.
Last modified is going to be sent, but there's a bunch of checks that use the E tag.
Well, if you have the E tag, then it sends it if non-match. If you don't have the E tag but you have last modified, it just sends if modified sends.
The E tag check is quicker, isn't it?
It's going to start the file anyway.
Yeah. I'll have to dig into that because I swear I set this up for a reason. But yeah. Listen to that guy. We're setting the cache control max age and public, saying this is publicly cacheable. So proxies, etc., are free to cache this. I think this is a month. And then if we have mod expires, then for different types, we'll set the expires headers to a month, I think. And this is after the request. See a bunch of syntax, lots of pages in the Apache docs on how to configure this to be exactly what you want. But we found it very helpful.
I think I know why you set the E tag. Because the default uses the inode.
Yes, which is
bad.
Terrible across clusters. But if there's a way, if we actually don't need it, it might just be easier to unset it. I'll have to play with that. But you can basically set this up so that you're serving your CSS to be cached for a day, and your JavaScript to be cached for an hour, and your images to be cached for a month. And that really helps with client-side and server-side performance with a built-in Apache module. So, something to look at. Yeah, there we go. Here's my other favorite, is I use ModDefuse cache. Partly I use that because I'm running a 3-tier application, so most of the assets that I'm serving are not coming from the local file system. They're coming from JBoss. So I'm using mod proxy to issue requests back to JBoss, and JBoss is serving stuff out of an EAR file or a WAR file. And some of that isn't cacheable, right? Dynamic JS piece, great. But a lot of that is images, JavaScript, CSS. There's a lot of people who will, in their deployment process, will deploy static assets, JavaScript, images, CSS, etc., to the web servers directly. And in the WAR file, or other application bundling, they just have dynamic code and content. I hate that, because as a developer, it means getting your local environment working is always a pain, and keeping it updated is always a pain. It's a real problem. And so a lot of people, places that do this, you'll see developers who are running a given application with no CSS and no images. And they just get the raw HTML and they're clicking through and it looks terrible. If you use ModDefuse cache, you get all the advantages of doing it the hard way, but everything's easy for your developers. Everything goes in the WAR file, everything runs everywhere, everything's versioned, everything's tagged in Subversion, it's all easy. Everything that's application related is right in one deployable archive. But your Apache instance on your web server is caching all that static assets for you and serving it locally off the cache on the web server's file system. So you're taking the load off of JBoss, which is more likely to be a bottleneck than Apache, and you're serving those things right off the web server boxes without any hard work on anybody's part. You look at the Apache docs, and there's basically two caching modules. One is ModDefuse cache, and one is ModMemCache. And you say, hey, ModMemCache sounds faster because it's in memory. It's buggy. It is absolutely buggy. Under load, it will fail in weird ways. I tried it, and it's just not worth doing. Mod disk cache is great because it uses the kernel's own file caching algorithms to cache the files in memory for you. So you don't have to worry about setting your mod mem cache max size to something smaller than your free memory on your system and worry about running out. Not a problem. The kernel manages it all for you, and you're serving it from files on the disk. So basically, mod disk cache takes the file, usually coming from your JBoss or Ruby on Rails or whatever application you're sitting Apache in front of, takes the file, saves a copy to the disk, and we'll save one gzip version, one non-gzip version, so everything's ready to be sent out to the browser. And then we'll serve that right off the local disk to all your clients. But the kernel gets in the way and says, hey, you're accessing that file an awful lot, let's store that in RAM. I've got some free RAM memory. And it'll do that until you run out of memory. And then it will happily reduce the size of its cache because the kernel manages its cache and buffers kind of automatically. That's one of the reasons that if you do like top or like free -m, you'll see like, oh, where'd all my memory go? Oh, the kernel's using it. And it's using it specifically for performance improving your applications, which works out great for this kind of stuff. So it's a much smarter, much safer in-memory cache for files for Apache to serve. You can do some crazy stuff. Apache's got some options where you can basically use kernel direct access to pull file stuff. Again, it's one of those optimizations that is more trouble than it's worth in my opinion, because you can still max everything out doing it the easy way. So I just generally use mod disk cache. Warnings, doesn't clean itself. There's an HT cache clean job that you can set up to run periodically to clean it to a certain size. If you don't pay attention to your headers, that's where the unset vary comes in. You can end up with tens of thousands of copies of the same file, particularly if you have vary on user agent, because there's 10,000 Firefox user agent strings and 10,000 IE user agent strings. Every version, every ISP that shipped it, every plugin, everything is tagged on, and all of a sudden you're caching 10,000 copies of a CSS file. It's the same. So do pay attention to your headers if you're using mod disk cache. The other thing that can really mess you up is dynamic URI content. Obviously, you're generally not trying to cache JSPs or, I'm Java-centric, but apply this to your own application. But sometimes you can have an engine that generates URLs or URIs that look like this. So blah.jpg, semicolon, jsessionid.foo, or equals foo. And it will cache a separate copy for every one of those because it's a different URI. And then you run the same problem. And as soon as you're caching unique copies, you're causing a lot of downside effort for no win at all. So when you do set this up initially, pay attention to what grows in the cache. You can look at the header files, they're all plain text, which is great. So you can look at them and say, oh, I've got 10 copies of this, why? And it tells you why. And the other piece that you have to keep in mind, yes?
So the solution to the JSessionID problem is to not run JSessionIDs in your URI?
Yes. For static assets, yes.
There's a similar problem if you run Apache on Windows, which is not case sensitive. You could have the same URL with different case.
Okay.
And it'll cache different multiple copies.
Gotcha. All right. Another reason to stay away from Windows.
Just don't run Apache on Windows.
Yeah, exactly. Why would you do that? The one thing to remember is this is another layer where you're caching stuff. So if you're making changes and they don't show up on the website, look there. Cache copies. So especially if you have sort of a complex application, right? You're running JBoss. You have an ear. You have Apache sitting in front of it. You've got Akamai sitting in front of that. And you have browser cache headers turned on. And you make a change in a CSS file in your WAR, in your ear. It's cached in like 12 places, right? It's cached on your local client. It's cached in Akamai. It's cached in Apache. It's cached everywhere. So you do need to go through and blow this out if you're in that situation. Lifespan depends on the headers, right? So if it's a short lifespan cache header on the object, then it's not a big deal. But if you're setting cache times for a month for static images, it can definitely bite you. Just a thing to remember, oh, that's why it's showing up wrong. Yeah. So this is kind of a default config. Again, this is one of the situations where the default settings are bad. The dir levels and dir length, I forgot what they are out of the box, but they're larger. And so you end up with these really deep trees. Who's familiar with how this stuff works? I don't want to bore people if they know, but all right, I'll bore you all. The way this works is for a given asset, it computes a unique identifier for it, basically like a hash using certain aspects of the file URI and headers, and it creates a directory structure that has the first part of the hash is the first level. So A, B, C, D, E, through 0, 1, 2, 3, 4, blah, blah, blah. So you get 36, or I think they do capitals too, so it's like, 50, 60, whatever, directories. And then under each one of those, it does the same thing, and does the same thing. So you get this giant tree. The defaults for this are large, and you end up with a very big, deep tree, which is slow to parse for the kernel looking for a file or writing a file, and is really slow to clean up because most of these directory nodes are empty, right? So you're only caching, say, 1,000 files, but you've got 100 million directories. 99% of them are empty. But to clean out your cache, you still have to go through an rm-rf, and it iterates through this entire tree and takes forever. So bad defaults. So I do 2 levels, their length of 1, and that gives me a single letter, and it gives me 2 tiers, which is 50 something or 60 something times 60 something, which is good. You end up with 1 or 2 files per level usually, or per end directory, and that's great. And it's fast because you're only going 2 levels deep, and it's fast to clean up. So this is one from People's Choice Awards. So enable cache, disk, path. Max size, default expire for assets that don't have a expiration header. So I'm saying let them go for an hour, and ignore the set cookie header, because the set cookie header is going to be different for every client request. So you don't want to be caching a separate version. So basically say, when I'm looking at headers to determine what's unique and what's not unique, make sure you ignore that. All right, I guess you guys have had a previous presentation on ModDefuse speed, so I'm not going to go down to the weeds on it. What I will say is that it is nice, and as a developer, a lot of the things that you should be doing for optimum performance are a pain to do for development purposes. You want to be serving up one CSS file, but maybe it makes sense for development to have your CSS broken up into 3 or 4 different files, each one managing a specific library that you're using, or a specific type of functionality, or is managed by a different team, or whatever. Most sites I've seen have many CSS files, many JavaScript files. You should munge them all together, you should minify them, you strip out all the comments. That's a real pain, and I think it's not something that developers should be worrying about, and it's better to let developers manage it the way that makes the most sense for the development process, and have somebody else deal with shrinking it and aggregating it into a single file. That's one of the things that mod PageSpeed does, which I think is nice. You can also use something called pack tag if you're doing JSP development. It's a JSP tag library that will do that aggregation, minification, and compression for CSS and JavaScript assets. So it's another option. It's pretty cool. Free. Yeah, so I'm not going to go into it too much. Open source, it's free, tons of filters, very configurable. It'll do image compression and optimization like Smushit does. It'll combine and aggregate your JavaScript and your CSS. It'll automatically generate sprite files for your CSS background images, which is another thing that I just think is a pain to manage. I think sprites are great, but like I hate having opening up sprite files and making not my thing. Domain sharding is another one of those things. Yes.
I'm sorry, can you talk about the sprite images a bit more? What's it doing? You have a bunch of images, assets that you downloading it?
So, yeah, so what it'll do is it'll look for images, small images that you're using typically as background images in your CSS for styling your site. And instead of it being served out as 16 images, it munges them all into a single image and then uses relative positioning to mask out the sub-image in the big image and rewrites the CSS.
Is it modifying your CSS?
Yeah. Yeah. It modifies all kinds of crazy stuff. Very configurable, again, so very like a million ways you can tweak it. But for people like me who don't like generating sprites and dealing with sprite files, and I'm sure there's people who are very good at it, but I'm not. Just handling it is good. Domain sharding is another one of those things. Most browsers can only request 4 to 6 to 8 assets off a given domain at the same time. So you're loading 100 assets off your domain. That means you're doing it in groups of 4. 4 requests. You wait for your 60 millisecond latency, some more time to respond, to get the request back, and you issue the next 4. So that's why you see the kind of tiered stack of assets loading. Domain sharding basically dynamically sets up subdomains so that you can issue many more requests simultaneously. So you're issuing 4 requests to statica.mysite.com, 4 requests to staticb.mysite.com, 4 requests to staticc.mysite.com, and so on. So you're able to issue many more requests simultaneously, and it does it automatically. So it rewrites your URLs for these static assets across some set of sharded partition names that you have CNAME back to your primary web server. Again, stuff that you could do manually, but is a real pain to do and manage. Yes?
So I've got a popular homepage that's downloaded millions of times. Does this get done once and then cached, or is it done a million times?
The rewriting is done once and cached in the plugin. And then when your browser client caches all the assets, hopefully it's only doing it once. But yeah, most of the optimizations that this does, it does and stores the optimization that it's done. Whether it's compressed images, or rewriting the HTML to do the domain sharding, or spriting the images, etc., it's done once. It does 100 other things. Again, I don't want to get too deep into the weeds on this one, but in the realm of Apache performance and things you can do with it, definitely worth a look. When it first came out, it was really buggy. It would break all kinds of common web applications. Right now, it's really good. So, give it a look-see. Yes?
What if you end up in a situation where you're actually generating images and then you have to zone them back out? Would it build sprites for those or stuff like that? Or?
So spriting is usually used for small,
like icons.
Yeah, icons and
images.
Yeah, little styling pieces.
So it does it based on size.
You can configure it, but usually it's stuff that's referenced to CSS background images. For dynamically generated images, it will do the image compression on it, which is really nice. So you can set a quality standard that you want, and it'll dynamically, recompress basically, like Smush It or some of the other services out there. It'll do that. With dynamically generated images, another thing is if they're going to be pulled by more than one person, ModDefuse cache is fantastic for that. So you're not dynamically generating the image every time. If it's a one-time deal, like a mailing label or something like that, not a huge deal. But if it's an image that's being pulled a bunch, you're generating out of database, or you have some sort of something or other generator, and you're going to be serving that image out thousands of times to thousands of people. Definitely makes sense to cache it, and definitely makes sense to smush it. And this will do that for you. Again, does 10 other things. Go look it up. Definitely explore it, play with it. Bunch of options, pretty advanced stuff. Mostly stuff that saves you or your development team a lot of headache trying to manage or do manually. So.
Yeah, so one more you add to that. So the guys who write a lot of PHP, they work in Google, Warehouse River, so they're really close. We had the team leading about PHP come and speak about it here a couple months ago. It's changed a lot since then, so we didn't want to bring him back. It goes to shoot an email, and we can try to get back here. Todd Morantz is a good guy, and he really leads the team. So
nice.
Come by and talk about it.
I'd love it. All right. So like I said, I mostly deal with 3-tier applications. So web servers, app servers, database. A great place to use Apache because Apache will provide SSL termination, load balancing back to your application servers via mod proxy or mod cluster. And you can run mod security, which gives you web application firewall for free. Web app firewalls block attacks against web applications, so different than a network firewall. Very useful if perhaps you take credit cards and you need to be PCI compliant. In the PCI stats around dealing with web attacks, you either have to have a third-party tool or team pen test and audit your application after every release, or you need a web app firewall. It's free, runs in Apache, big fan, and much cheaper than pen testing your application after every release. The security guy in me says do both, right? But if you're only going to do one, it's free, it's cheap, it's easy. So yeah, basically by putting Apache in front of your application server, you can build a cluster, you can do load balancing, you can do all the stuff we talked about as far as caching and mod gzip and mod page speed and all that good stuff. It also gives you a good security win because you're firewalling off your application servers where you have the sensitive data, more code and dynamic content and access to your database. Separate server, separate hardware, helps with PCI compliance. So anyone doing anything, you got to worry about that. In Apache 2.4, Mod Proxy Balancer gets some huge upgrades, much needed upgrades in my opinion, that bring it up to or better than Mod Cluster. So stuff around building clusters of application servers dynamically. So adding new JBoss nodes in, or Ruby on Rails nodes, or any application that you're running in the background. Add them in dynamically, route traffic, balance traffic dynamically, and my favorite is session bleed off. So you can set a given node and say, existing users who have a session on this node, keep routing them there, but no new users. And after half an hour, 45 minutes, you've got 0 live sessions on that node, bring it down, you upgrade it, you redeploy the application, whatever it is, you add it back into the balancer. And you can do 0 user impact rolling deployments in the middle of the day. So big win. That's with 2.4. Then with Apache, like I said, you can build out these scalable clusters. So you can start adding a bunch more application nodes behind things. You can do a really cheap and easy redundant setup. You get a virtual IP, so an IP that will route to multiple servers within a subnet. You use Heartbeat, which is a free package. And basically, Heartbeat checks to see what node's up, and Heartbeat will manage that virtual IP for you. So virtual IP gets assigned to one of these web boxes, and then Heartbeat will make sure if this box goes away or dies in any way, the virtual IP gets assigned to the other one. So all of your traffic, your CNAME, or your A record, get pointed to this virtual IP and will go to whatever server is currently live as the master, basically. So this lets you have instant failover from failed hardware, and it's free. It's easy to set up. HA Proxy is a free high-performance proxy. Apache can do this. I put HA Proxy in front of Apache for these type of configs. So HA Proxy basically just load balances out HTTP and HTTPS requests to your Apache instances. So you've got a VIP, which handles your incoming traffic, HA Proxy, which routes your Apaches. Your Apaches are doing all the caching, the mod gzip, and the header manipulation, and all that good stuff. And then the Apaches are load balancing out to your application servers. And then your application servers are dealing with redundant database connections, using Oracle RAC or Postgres load balancing, or whatever it is that you're using. So you can basically build out a free, open source driven, completely redundant cluster that has basically real-time failover. So hardware failure is going to bring you down for 2 seconds and page you, but your site stays up, which is a big deal. When HA Proxy gets a little onerous, or you start needing to push more than a gig a second, so you don't want a VIP, you have to move to DNS load balancing. So you're routing requests to multiple front-end boxes. So at that point, you can rip out Heartbeat, you can rip out HA Proxy, and you can rip out your VIP, and you just use DNS to drive the traffic to different Apache instances. The simplest way is just round robin. So you get your request routed around. For People's Choice Awards during the show, that's what we use. So we set up 5, 10, 15 Apache servers. We point DNS to all of them, and everyone just hits them, because Apache basically never falls over. If you need more than that, there's third-party services and open source packages that let you do smart DNS-based load balancing. They'll check the health of each node before it routes requests there. That'll route requests to different nodes based on locale, a bunch of other stuff. So if you need to get more advanced, you can. But basically, Apache can be a very key component to building a very scalable, very high uptime, stable cluster. That's it. Yes? Yeah. This is like the question group right here.
So for those of us that are working with mainly PHP-based sites, would you have any comments on using things like fast CGI, FCGID?
I have no experience with those. I did PHP back a long time ago, and really haven't done much with it since, especially in the performance realm. So unfortunately, I don't have much good advice around the alternate ways of running PHP code. Sorry. Yes?
Now, on the round robin we were just talking about, I was under the impression that round robin was pretty much being abandoned, because if you have a single box with some kind of performance problem, it keeps getting traffic.
Yeah.
And it seemed like everything was going more smart metric based, so that way, based on load and things like that.
So, go back here. Round robin is stupid. in that it does not know anything about the endpoint that it's sending traffic to. That server could be down, it could be overloaded, it could be hacked, who knows. The upside to Round Robin is that it's free and it's incredibly easy to set up. And if your Apache instances are up, it works great. And like I said, this is what we use for People's Choice Awards because, like I said, it's never the bottleneck, so we never have them falling over. And I've never, think about that for just a second before I say never, almost never have I had Apache web servers lock up and die on me. One situation, very, very, very weird stuff. In general, I don't worry about my Apache servers. You gotta have good monitoring and low TTLs. So if you do have critical hardware failure in one of your boxes, right? Hard drive dies, motherboard goes up in flames, rats are eating your cables, and it's going to be 5 hours to replace it. You don't want to be sending, a quarter of your traffic to a null IP. What you can do, if you want to be a little crazy, is you can do the same VIP heartbeat setup. So each node gets a VIP, and each node has a heartbeat partner. So if the box dies, its VIP gets failed over to its partner, and now 2 VIPs are pointed at one box. That works pretty easily. The problem, so the metric-based smart DNS load balancing is much better, but usually it's either expensive or very difficult to set up. I haven't found a free package that lets me run that easily.
I don't have a package, but I ran into a problem once, a failing network card. So it was up and it was throwing out a ton of errors. So anytime you hit that particular one, it was just crappy performance. Using something smart could detect and kind of go, eh.
Yeah, again, I think it's good. I guess, I don't know, a lot of what I'm trying to talk about here is stuff that's free, open source, very easy. You get into smart DNS load balancing. A problem, again, that I don't think you really need to get into until you're pushing more than a gig a second. Because if you're pushing under a gig a second, the VIP and HA proxy works fine. HA proxy is very smart about the nodes, generally works pretty well. If you're pushing more than a single box, you need more than one IP to drive traffic to. I think that's when you really need to get into the DNS piece. But if there's anyone who has a good either open package or even a paid provider that they really like that provides smart DNS load balancing, I'd love to hear about it, and I imagine other people would too. So,
just one comment with respect to the round robin approach. You can use HA proxy and do a very simple check against your Apache web servers to see, and you can set up that check to be whatever it is that constitutes that web server to be up. So that way, HA proxy will not send any request to your Apache server if it's unavailable.
The issue is with the DNS round robin, if the box the DNS is routing to is down, there's no HA proxy involved. Yeah, but yeah, if you run HA proxy or you run the VIPs and heartbeat, then you can kind of work around the problem. But if there's a good smart DNS solution that's cost effective, I totally would recommend that. If you are using a CDN, a lot of them provide that functionality as part of the CDN. So you can say, I want load balanced origins, and here's health checks, right? So that could be a nice way to do it if you're already paying for a CDN. Something to think about. But. Anybody else?
Have you ever run out of ports?
Ever run out of ports? I've never run out of ports. Yeah.
Do you know how to deal with that if you do?
I mean, you throw more boxes.
So,
the problem.
The problem I'm seeing is a lot of ports getting into the time wait state. So you need to wait for them to time out.
Yeah, and that definitely, you can adjust the TCP timeout window on the kernel.
Bring that down to 5 seconds or something.
Yeah, at virtual IPs, you should get, when you get the...
Pay for extra IPs for a single box.
Yeah, it depends on your provider. But yeah, ideally you shouldn't be paying more than $1 an IP, ideally. So getting an extra 8 IPs. So each IP is going to give you, what?
There are no more IPv4.
I don't know. I use SoftLayer, they get tons of IPs. But yeah, so every IP that you have for ports is going to give you 64,000 ports, right? So every other IP you add, another 64,000, and so on. So I guess that's how I do it. I'd throw a couple extra IPs on there and call it a day. Anybody else?
Just one other question.
Yeah.
With respect to the benchmarks that you have, In your environments, are you using some sort of virtualization software?
I'm not, and there's a few reasons why. One is that most of our clients will max out their hardware, so putting the overhead of a virtualization layer doesn't really buy us much. I think virtualization is great when you're either using less than a full server or when you have these kind of elastic scaling needs that can't be dealt with real hardware. The other problem is, for us at least, the database layer, Oracle, and the applications
I'm sorry,
here.
I have to catch a train.
Oh, I'm sorry, I'm running long. I was worried I was going to be short. I was like, I've only got like 30 slides. Oracle and the application software that we're using, which is ATG, is licensed by the court. So you can't scale dynamically on either of those layers. And again, Apache is never the bottleneck. So scaling elastically on that point, it's not worth the hassle. The other problem is if you're doing VMs in a shared environment, so you have multiple end clients who are using the same infrastructure, or if you're using the same infrastructure as other people, it's very difficult to get PCI certified on that. Amazon finally did it. I think a couple other people have. A lot of people aren't. And so if you're doing any kind of e-commerce, it's kind of a minefield at this point if you're going to be dealing with real auditors. So this is why I don't do it. There's a lot of applications and a lot of use cases out there that I think it's really great for, but personally I don't have really much experience with it for that set of reasons.
All right, let's take that.